Let's continue with the code from the previous clip. I'll expand the window, Alt-E. So if we look at this for I in range, what this part of the code does is simply count number of entries inside a range. In this case, block list is a list we've created, and it contains 72 entries in our case. It should be 70 city blocks, but we've got 2 times 3 extra, so that makes 72. So that is 72 strings, but it's a list with 72 strings in it, and length then simply returns a numerical value for that. So it looks at how long is this list, it's got 72 elements inside it, so it returns 72. And then there's this part of the code. I've just explained you this earlier. So this goes, if I is equal to, and I being the index number we're looking for, is equal to the first index you find its value at, then store it in the filtered list. So if we're looking for block list index number 20, and it finds the value that belongs to index number 20 for the first time at index number 20, i.e. these two match, then it's going to store that in this list. If we look for index number 5, it's going to retrieve block number 3, but it finds that for the first time in index number 0. So it's not going to store that. So block list 3 will get stored once we look at index number 0. That's block 3. And then it's going to say, okay, I find block 3 for the first time at 0. Store it once. Then the next 2 times, these two don't match, and they don't get stored in the list. So we only have 1 left at the end. And that way we can filter out the duplicates. And this is of course important because if we would not remove the duplicates, we would get 3 file nodes at some point, each importing block number 3. So we get 3 times block number 3, and that's going to create a mess. So now that we have our filtered list with every entry only once, we can go ahead and import the blocks. There's one more thing I want to show you. Let's go underneath block list and do print block. Now if we hit import, we can see that we have the path plus a blank line. This blank line is going to be translated to a /n symbol in our list. Let's remove that, and we can do that by indexing. So what we can do here is we can say from block, so from that entire path, we want everything except for the final entry. So we do :-1, and if we print this now, that only gives us the paths without the blank lines. So we're going to filter for that as well. Let's remove that and continue under here. Let's make a for loop for block in filtered list, :, and we're going to put down file nodes for each entry. So file node is who.node, and we're going to say this node dot create node, and the type of node we're creating is going to be a file node, and then we're going to have to set the parameter. So file node dot parm, and which parm are we setting? Well, it's going to be the file parameter dot set, and what we're going to set it to, I've just shown you this. We're going to set it to block, and then we're going to do this square brackets open and close :-1, and this is going to retrieve from block everything except for the final part, which is the blank line or the /n symbol. We'll also have to create a merge node. Let's create that here. Merge is who.node. We're going to create it inside this node, so like this with a dot create node, and the name of the node we're creating is a merge, like so. And underneath file node, we can just say merge dot set next input and mind the camel case, and we're going to set a file node to it as a next input. This is opposed to having a counter, right? So now it just goes, oh, it already has an input. We're going to set the next loop into the next input. So every time this loop runs, it's going to set the file node it creates in that loop as a next input to the previous ones. So now in theory, the code is complete. Let's remove any print statement we might have. We don't have any. So let's hit import and see what we get. No errors, so let's jump inside, and we should have a bunch of nodes right there. If you select them all and hit L, it will lay them out for you, and we can see that we have a merge node with a bunch of file nodes connected to it. So file 71 and file 70 have paths to them, and this is just the original file node. You can delete that, and if we visualize the merge, hopefully that gets them all. And let's check the ones up top. If there's anyone erroring or missing a file, it would be red or yellow, but they all seem good. All right, and if we look at our viewport, we see that we have a bunch of point clouds right there. Now all we have to do is just move them to their original positions, because of course all in the center is not all we want. Let's minimize this. Let's drop down a point VOP, visualize it, and wire this in. And to the position that we have, we're going to add the original block position. So let's drop down a bind, and inside it we're going to get a vector, which is the original block pos. And we're going to add this to the position of each block. There we go. And now we're looking at a city entirely with the commercial buildings in the middle and the houses around the centers. Let's go back up from here. Let's have a quick look. Let's visualize the normals and the up vectors. Should already be there. We have the up vector pointing up, and we have the normals pointing in whatever direction the buildings are rotated. Let's make a quick box and a copy node and copy them on. And this way we can verify that we actually have the rotations working. So these buildings will be aligning at some point to the actual road. Of course, these are not the buildings, but once we do, with their different sizes and such, we should have them all perfectly aligning to the roads, and we can build up from there. Let's remove these and append a null node. Let's color it green and call it out base city point cloud. And that's it for this module. In the next clip, I will run you through a recap of this module, and in the next module, we'll pick up from this point cloud and start building our towers on top of that. See you in the next clip.